The acceleration is directly proportional to the displacement. When the displacement is in opposite direction, then its acceleration is directly proportional to displacement. Here A is acceleration. A is acceleration. Y is displacement. Y is displacement. Here minus sign indicates that its acceleration is when its acceleration is directly proportional to displacement when it is in opposite direction. So we proved that this this reference circle, a particle performing on this circle is also SHM. Now we see some slides. Motion. The change of displacement of a body is called motion. And what is displacement? It is the shortest distance between initial and final position of a particle. And what is acceleration? The rate of change of velocity is called acceleration. Motion is classified into two types. What are those? Periodic and non-periodic motion. What is periodic motion? The motion which repeats itself in regular interval of time is known as periodic motion or harmonic motion. Example of periodic motion is vibratory motion, uniform circular motion. And non-periodic motion, the motion which does not repeat itself at regular interval of time is known as non-periodic motion. Example of non-periodic motion is rectilinear motion and curvilinear motion. So what is simple harmonic motion? If a body is said to be in SHM, it moves to and fro motions about its mean position. Dear Sparrow, a body is said to be in SHM, it moves to and fro motion along a straight line about its mean position such that any point its acceleration is directly proportional to displacement. There are so many periodic motions is there. When the motion of vibratory motions of a bridge, when vehicles are move, the bridge can oscillate, and the electric power has the wires. The wires also can move in periodic motion. Aeroplane can move, the periodic motion of a guitar, and these all are the periodic motions. These all are the periodic motions, but not simple harmonic motions, because simple harmonic motions has three conditions. Friends, dear friends, who is this? Hello, dear friends. So these all if these all are the periodic motions, these periodic motions are not simple harmonic motions. There is three conditions. So now we see those all are the periodic motions, but all the periodic motions are not simple harmonic motions. There is three conditions for a body should be simple harmonic motion. The motion should be periodic about a fixed point, and the acceleration and displacement should be always in opposite direction, and the acceleration should always be directed towards the fixed point. These three are the conditions. So now we discussed about the parameters of simple harmonic motions. In simple harmonic motion also the force is formed. Now we discussed about force law in simple harmonic motion. Force law in simple harmonic motion. So what is the Newton's second law? Right. F is equals to ma. So now what we know very well, acceleration A is directly proportional to minus y. A is equals to minus omega square y. So F is equals to m. Now we substitute the value of A. It means minus omega square y. Here let we take k is equals to minus m omega square. F is equals to k y minus ky. When if a body should be in SHM, the force law of SHM is F is equals to ky. It is the force law in SHM. In SHM, energy also form. What is the energy? Now we find the energy in SHM. Energy in SHM. What is equation of kinetic energy? K is equals to of mv square. Of mv square. If a particle is performing on a circle, the velocity of... Hello?
Hello?
Yes, Swaro. What's your question?
Yeah, I'm Pooja Swaro from Narsingi.
Yes, Swaro. What's your question?
What is uniform circular motion?
What is uniform circular motion?
Circular motion.
Yeah, nice question. Uniform circular motion means if a body can move in if a body or a particle can move in circular motion, it means uniform circular motion. The example of uniform circular motion is solar system. The sun is the center and the planets can around the sun. So when the planets can around the sun in circular motion, means it is in uniform circular motion. Are you clarify your doubt? Okay, thank you. So the kinetic energy means K is equals to half mv square. If a particle is performing on if a particle is in SHM, the velocity of particle v is equals to K is equals to of mv square. Here the velocity of a particle, when a particle is in SHM, v is equals to a omega cos omega t mv square. So a omega cos omega t whole square. K is equals to half m. Now we are squaring a square omega square cos square omega t. Now we consider here also m omega square is equals to k. Let so k is equals to half a square m square omega square cos square omega t. It means k is equals to half a square k square cos square omega t. When a particle is in SHM, the energy of a particle is half a square k square cos square omega t. So friends, in our daily life, how we are using SHM? We find out the time period of a simple, by using this simple harmonic motion, we finding the time period. So friends, in electricity, the producing the electricity in turbines, we calculate this simple harmonic motion. Easily we can find out the time period. By using the Newton's laws, we find out the time period. But using of this simple harmonic motion, we can easily find out the time period of a periodic motion of a body and turbines in turbines producing electricity, producing turbines, we using this electricity, it is easily can find out. Thanks for giving this opportunity. Thanks to one and all.